In this video, we're going to be having a look at the binomial expansion of this function here. So we were asked to write down the first four terms, and then we're going to be looking at how you can use that expansion to predict some approximations to root 26. So let's start off with that part A, and we've been asked to just get that in view. Okay, we have been asked to take the expression 1 plus 4x square rooted and do the binomial expansion of it. Well, the first thing you need to do is write it as a power like this, and then your binomial expansion formula always works if you've got a 1 there, and then whatever is here is going to be kind of like our variable. So whereas you might expect to see an x there, here we've got 4x, so we're going to be using that 4x in the binomial expansion. So let's start off. The first term in your binomial expansion is always 1, and then it is n, so the power multiplied by that term there, and then it's n times n minus 1 over 2 factorial times by that term there squared, and then n times n minus 1 times n minus 2 over 3 factorial times by that term cubed. Let's just check. I want to stop there, but I want to check that I'm going to have 4 terms. Yes, 1, 2, 3, 4, 4 terms. So our job now is just to simplify this as much as possible. So the first ones are fairly straightforward. 1 half of 4x is 2x. Here we have minus a quarter over 2 factorial, so minus 1/8, and that 4 squared is going to make 16. So minus 1/8 of 16. And here, if we have a quick look at this one, you can type this on a calculator as well, to be honest. What does it come out to be? It comes out to be a plus 4. Okay, this part, so you've got to do a half times minus a half times minus 3 over 2 divided by 3 factorial. But then remember, you're multiplying that number by 4 cubed. Okay, so you should get 4x cubed, like that. Okay, let's have a look at part B. It says explain why x equals 25 over 4 should not be used in this expansion. So for this, you need to know that whenever you're doing the binomial expansion for fractional or negative powers, in other words, anytime that you get this infinite series of terms, you cannot use a value of x which is going to cause the expansion to be divergent. Your value of x chosen must cause the expansion to become convergent. And in order to be able to sort of tell that, what you need to do is let's write this out again here. So this term here, the 4x, must be less than 1. In real, actually, it should be the modulus of 4x is less than 1. And what that does is ensures that each successive term of your series is going to be smaller and smaller and smaller effectively, so it's becoming a convergent series rather than a divergent one. If we divide both sides of this condition by 4, we get that the modulus of x must be less than a quarter. And in part B, they're asking us to explain why x equals 25 over 4 is no good. And the reason that it's no good is that 25 over 4 is actually not less than a quarter, it's greater than a quarter. So it should not be used to make any approximations. Okay, part C asks us to explain how we could use x equals 100th instead to find an approximation to root 26. So let's pop in x equals 100 to, got that wrong, first thing. 4 times 100, 4x, so 4 hundredths. Now that doesn't look like it's going to help us to find an approximation to root 26, does it? 1 plus 4 over 100 doesn't seem very much like root 26, but let's just work on it a little bit. Let's add those two together, and what you will get is you'll get the square root of 104 over 100. The square root of 104 over 100, if you divide by the top one, sort of simplify that fraction by dividing by 4, you get the square root of 26 over 25. The square root of 26 on the top of the fraction, and the square root of 25 is 5 on the bottom of the fraction. So you can see by substituting x equals 100 into this expression, we've shown that it would equal root 26 over 5. And therefore, the expansion that we worked out earlier, if you pop x equals 100 into that expansion, you will get an approximation for root 26 over 5. Not root 26 itself, but root 26 over 5. So the answer to this question, how would I use x equals 100? Well, I would substitute it into the series found in part A. But because I'd be working out an approximation for root 26 over 5, you would have to then multiply by 5. So for this question, if we just read back to it again, it says, explain how we would use x equals 100 to find the approximation to root 26. There is no need to carry out the calculation. So I don't need to actually work this out. This is really what they're looking for. They're looking for you to explain how to do it. So substitute the value of x into the series from part A and then multiply by 5 and have this working here to back up your answer.